So let's first talk about some of the rules of exponents before we begin multiplying and dividing monomials. So properties of exponents right here, the rules of when you're multiplying them is that you add the exponents. When you're dividing exponents, you would subtract them. When you have a negative exponent, it means to flip it to the numerator or the denominator, depending on where the negative is. So if you look at this, it's a negative, so it would be flipped to the denominator. If you have a power to a power, you multiply the two exponents. If you have a power of a product, you distribute the exponents. So that means if you have an exponent outside parentheses, you multiply it through both things in the parentheses. And if you have a power of a quotient, same thing, quotient means division or a fraction, then you distribute it as well. And if you have a negative, you actually flip it. And then the last one is if you have a zero power or zero exponent. The zero exponent means to change whatever the zero is attached to a 1. So those are the rules that we're going to apply. The other set of rules we need to know is simplifying monomials. There are 4 things that you need to look for when you're trying to simplify, and they are: make sure you have no powers of powers. That means you have none of these right here. And then each base appears only once, and all fractions are in simplest form, and there are no negative exponents. So we're looking for these things when we look at our problem. So let's look at our first problem, which right here, we have our first problem. So we want to simplify as much as possible. We have negative exponents, we have base A repeats, and we have numbers that can be multiplied. So we're going to go ahead and start to simplify this. So the first thing I'm going to do is look at the first one, and that will be a 2, and I'm going to flip the A to the second down to the bottom because that's the negative. And then I have a parentheses, I have a 3, and I have an A cubed and a B squared. And then in the next one, I have a C that goes to the bottom. So I'm just going to put a 1 down here and put the C squared on the bottom. So what I have is everything, the negative's gone. So now anything on the top can be multiplied. So 2 times 3 times 1 is 6. A cubed stays A cubed. B squared stays B squared. And I just want to make sure that that's appropriate right there. And then on the bottom, I have A squared times C squared. So A squared times C squared. So the next part of simplifying is we need to get rid of the same bases. We have A's that repeat. Well, quotient means we subtract. So I'm going to take 3 minus 2. So I'm going to get 6A, because 3 times 2 is A to the first power. B squared, nothing happens to it because there's only one base. And then the C squared, nothing happens to it because it's the only base. So our bases are all the same. We have no negative exponents. Our fractions reduced and our numbers are multiplied. So this problem is now simplified. Let's look at the next one. I have Q's, I have R's, so the bases, so I'm talking about this part right here where each base appears exactly once. So I'm going to subtract the exponents. So if I subtract 2 minus 7, I'm going to get negative 5. And then the R, 4 minus 3, is just a 1. Well, we have a negative exponent, so we have to simplify that by flipping it. So our Q then goes to the bottom of the fraction, and this is to the first power. We just don't write the 1 for the R. And now I look, my Q, my R have no negative exponents. I have no bases that are repeating. So I meet all the 4 criteria, so this is simplified. Let's look at the last problem where I have a 3 outside. 3 means that, so I'm looking over here where it says the power of a product. Power of a product means I'm going to distribute that 3 to each number. So the negative 2 to the third power will become, so I'll write it, negative 2 to the third power. And the power to the power means I'm going to multiply the 4 times the 3. And then the B squared gets distributed, so that'll be B to the 6th power. Now the only thing that I can simplify is this part right here, which will give me a negative 8. And A12 stays A12, and B6 stays B6. Negative numbers are all right. You just can't have negative exponents. So there is my answer simplified. So now we want to determine the degree of a polynomial, but we want to first know whether we have a polynomial. Okay, if you remind of a polynomial, you cannot have a variable in the bottom of a fraction. That's not a polynomial. You also cannot have a radical of a polynomial. So that's not. And I think other than those two things right now, you're looking for that, determine if you have a polynomial. So we don't have that in the first problem. So if we look at this first problem right here, there's no negative exponents and there's no radical letters. So with that being the case, we can then determine its degree. So the degree is of each polynomial, monomial I mean. So this monomial, this part right here, has a degree of 7 because we take the exponents of the variable. So we have x to the 4th, y to the 3rd, and if I add those, I get 7. So the degree is 7 of that monomial. Then I take this monomial, and I'm going to go ahead and use another color here. In this monomial, we look at the letter, and it has a 5, and it's the only 5, so the degree of that is 5. So the degree of the polynomial is the highest of the two. So in this case, this is the highest, so the answer is 7. Let's look at our next problem. We have a radical x which cannot be determined, and since this is not a polynomial, so it has no degree. And if we look at our last example, this one, if I were to flip that, because that's what a negative exponent means, as soon as you have a negative exponent, and I have it twice in this particular problem, I have the x goes to this bottom plus 6. Because of these two, this is not a polynomial. So to determine if you have a polynomial, we're looking for this. And once you determine that, you're looking at its degree by looking at each monomial.